The Sal'sk railway station is a major logistics hub in southern Russia. Dozens of tracks weave like veins and hundreds of railcars stretch to the horizon, with track workers in orange vests scurrying alongside. Amid that tangle sits, at first glance, an ordinary train, except for one thing. It's very long. 88 cars. That's roughly a mile, about the length of the Brooklyn Bridge in New York. But can a train be ordinary in a country that has been at war for 3 years? Especially here, roughly 130 miles from the front? Indeed, death is hiding in those cars in many guises. On some flat cars under tarps lies armored metal, infantry fighting vehicles with their guns covered like beasts asleep before a hunt. On others, howitzers loom, terrifying in their massive barrels, able to send death for dozens of miles. Then there are tank cars. Inside them is a thick, oily darkness. Diesel fuel, the blood of war without which no tank, tractor, or field generator will move. Everything around seems calm, measured, almost mundane. Only the wind running between the rails brings a faint unease, as if the ground itself senses that this night will be different. Now move 275 miles, about 450 kilometers west to Ukrainian territory near the town of Izyum, and go back roughly 3 hours in time. A deserted airstrip hidden in fog and night. 6 UJ-26 Bober drones sit on the concrete runway, plywood holes with serial numbers hand-painted in black marker. They look clumsy and unpresentable, but inside that clumsiness hides power, like a wolf concealed in a sheepskin. In that fragile plywood hull is the cold logic of a war of attrition. 3 years of fighting between Russia and Ukraine have shown one thing clearly. Victory does not always go to the side with the most sophisticated, electronics-packed weapons, but to the side with simple weapons produced in volume, so many they can be sent at the enemy by the hundreds. Take these beavers, as Bober translates from Ukrainian, 20 pounds of plywood, a couple of ounces of electronics, and 45 pounds of explosives that can be delivered 300 miles, about 500 kilometers. All of that costs about the same as a used Ford F-150, a few $1,000s. Compare that to a GMLRS M31 rocket for a HIMARS launcher. The same 45 pounds of explosives, but to reach only about 45 miles, roughly 70 kilometers, costs at least $200,000. And that rocket requires a launcher that itself costs about $5 million. So who wins? The side with 10 GMLRS M31 rockets or the side with 1,000 Bobers? Who will strike the enemy with 450 pounds of explosives or with 45,000 pounds of explosives? In the hangar, the monitors glow dimly. 3 operators, silent and focused, watch the telemetry. Each knows the mission. Nearly 300 miles of flight through the most densely contested electronic warfare environment on the continent. Everything is planned, but life is full of accidents, and on war stage, those accidents can multiply. On the command tablet, a green square flashes. Permission received. Launches are queued 40 seconds apart. The first motor coughs, then settles into a steady whine. The second, the third. Lights along the runway go out, and 6 pale silhouettes lift off one after another, climbing into the dark. A minute later, the airstrip is silent again. Somewhere overhead, at under 200 meters, the machines line up on course due east. A long road lies ahead of them, across the front, the border, and a night that will decide who survives until dawn. The first seconds of flight go according to plan. Steady speed, constant telemetry exchange with the ground station and reference points on the thermal displays. Operators receive data on position, altitude, and system status, and pilots navigate by warm signatures on the screens, river bends, rail lines, and power line towers that show clearly in infrared imagery. Then, almost at once, the background begins to change. Jumps appear on the monitors, telemetry freezes, satellite coordinates collapse and vanish as if someone turned off the lights. At first, they're written off as interference, short dropouts typical for an area with high radio noise, but a minute later it becomes clear this is not ordinary interference. Satellites fall silent, GPS goes dark, black boxes appear on screens where coordinates had been flashing moments before. Navigation signals are being swallowed and replaced with false commands. The enemy system is broadcasting instructions to land, return to base, or switch to the backup channel. Operators see what should frighten them. Foreign identifiers, alien coordinates, unknown markers blinking in the airwaves. Someone's trying to seize control. This is the moment of truth. Whose machine will win? The Russian war machine or Ukrainian military ingenuity? The UJ-26 Bober drones are not smart in the usual sense. They're crude but elegant in their simplicity. The Ukrainians anticipated GPS loss. The firmware includes a frequency hopping mode, a control method that changes the control channel thousands of times per second, like a radio jumping from station to station. While the enemy locks onto one frequency, the signal is already slipped to the next. It's not magic, it's math and synchronization, an idea that traces back to Hedy Lamarr, the Austrian-American actress who co-invented frequency-hopping spread spectrum, the foundation of modern Wi-Fi, Bluetooth, GPS, military comms, and many drone systems. Still, the adversary's reputation in this field is formidable. Land-based EW complexes can not only jam but also inject commands into the spectrum. Attempts to redirect controllers and force machines to land or return. On one frequency, the words Repellent 1 activated appear, the name of a new Russian electronic warfare system. Operators watch reports flash in the screens of the Russian command center. Interception test initiated. They expect the command signal to sever control at any moment, but the drones laugh at those attempts. Their control does more than hop frequencies. It uses pseudo-random synchronized patterns tied to onboard clock marks. Russian commands arrive, but the Bobers ignore them. As soon as one frequency is blocked, the craft are already operating on another. In addition, part of the flight is navigated visually by landmarks, river lines, roads, and railways visible in the thermal view. Where the satellite is silent, the Earth still speaks. This group of Bobers splits as planned. 3 craft go north, 3 turn south along the valley of the Seversky Donets. Knowing the terrain itself will cast them a shadow, the curvature of the Earth and the hills will hide them from the main surveillance beams of ground radars. The southern group settles into cruise at about 110 to 120 knots, roughly 200 kilometers an hour, at an altitude of about 80 feet, or 25 meters above the surface, low enough that any radar would lose them at a range of 12 miles, or about 20 kilometers. The reason is simple: the curvature of the Earth. Radio waves travel almost straight, and when a drone flies that low, it literally hides behind the horizon. For a radar mounted on a truck or a small mast, this is a dead zone. Past 12 miles, its beam will pass over the drone. Ukrainian operators understand the trade-offs. Miss by a kilometer to the left, and an S-300 will spot them. Miss by a kilometer to the right, and they'll enter the Tor M2 engagement envelope. Climb just 150 feet, and they would immediately appear on radar screens. It's a game of inches and seconds. Hold a steady altitude, follow thermal landmarks, read the traces of power lines and railroads to navigate when satellites fail, and always plan for surprises. A relocated mobile radar station, an unusual weather event, a stray signal that confuses the algorithm. The Russian command center detects the northern group and orders mobile intercept units to redeploy. The Russian commander must choose: shift forces north and weaken the southern sector, or disperse assets and risk both groups getting through. It's a critical dilemma, and every second of decision time gives the Ukrainian drones an advantage as they close on the target. Under cover of the dark night, 3 Bobers of the southern group run silent along the hills in the river's dark mirror. Their operators watch the screens, catch every thermal pulse, log interference signatures, and whisper short commands. They know the outcome of the entire operation depends on this stretch of route. The night keeps compressing space, and nothing feels accidental anymore. Risk remains. The imagery was 2 weeks old, and the enemy could have moved equipment in the meantime. The tactic is clear. One drone will act as a decoy, drawing the air defense fire, while the other 2, flying at extremely low altitude through the tower corridor, will attack the transformer from different directions, first disabling the cooling system, then the insulators, and finally the control cabinet to trigger a cascading failure across the grid. As they close, the southern group runs into EW activity. The spectrum fills with false commands: return home, land, switch to backup. Some telemetry drops out, but the drone's firmware includes frequency hopping and internal synchronization. Commands arrive but are not executed. Operators navigate by thermal markers and hard timers, course, altitude, and no radio chatter during the decisive run-in. When the drones enter the corridor, a Zu-23 Shoka opens fire. The decoy does its job. It climbs and draws a stream of tracers, allowing the other 2 to pass almost brush-like close to the power lines. The two drones strike from opposite sides in tandem. The first strikes the transformer base, rupturing the oil tank and disabling the cooling system. Hot components meet oil, vapor flashes, and a jet fire erupts. Seconds later, the second drone hits the control cabinet and the high-voltage terminals, disrupting switching and protective logic. High-voltage breaches damaged insulation and heated conductors, producing massive electrical arcs. Those arcs trip protective relays and selectively cut neighboring sections. The result is a cascade of protective shutdowns that severely degrade the integrity of the grid and the operation of early warning centers. As a consequence, some fixed radars and command nodes lose power and go offline for reboot. Mobile Panzer units do not lose power, they have their own generators, but the data exchange, early warning, and centralized targeting network is seriously disrupted. Instead of a coordinated defense, there remains a set of isolated platforms forced to operate with degraded situational awareness and slowed information flow. That creates a window for the main strikes on the military echelon. The southern drone group hugs the Seversky Donets Valley. Just under 50 kilometers remain to the substation, about 31 miles. On approach, the operators use thermal landmarks, river bends, rail lines, power line towers, everything that stays visible when satellites and GPS go silent. Recon has identified a potential vulnerability. Roughly 800 meters southwest of the substation stands a tall cellular tower. Military calculations suggest its reflections could create a narrow corridor, a zone where the effect of the Repellent 1 EW complex weakens due to geometry of reflections and interference. That's their chance to reach the transformer. While crews at the substation scramble in frantic attempts to stabilize power, the crews assigned to destroy the echelon receive the order to go. The second phase of the operation begins. The military train is engaged by the second group of strike bombers. The approach to Sal'sk station has been calculated and formalized. All synchronization actions are driven by local clocks on the onboard systems, and radio is not used in the final stage to avoid creating extra electromagnetic signatures. 3 bombers take pre-assigned approach corridors, one on a higher trajectory to distract and increase the chance of manual targeting, a second on a medium trajectory, and a third on a very low line as close to the ground as possible. Synchronized arrival means they reach the target area within seconds of each other. The Ukrainians succeed. Fortune favors the bold. The first drone strikes the locomotive's engine compartment, immobilizing the echelon. The second hits a fuel tanker. The third strikes a car identified by reconnaissance as carrying shells, triggering a localized detonation. The combination of the breached tanker and that detonation rapidly spreads fire through a number of cars and sets off a series of secondary explosions running along the train. The operation is accomplished. Most of the equipment, ammunition, and fuel destined for the front will never arrive. This is only one of thousands of episodes, small, surgical, and at first glance unremarkable. But the sum of such actions creates strategic change. As hundreds of streams feed one great river, so these efforts gather strength toward victory. We can only wish the Ukrainians that their streams merge as soon as possible into a full river called victory, and may that river bring peace and reconstruction to their land. Thank you for watching. We'll be glad for your like, comment, and subscription to our channel. See you soon in our next videos.